geobyte.
Similarly, let us take the another important problem. Okay, look at the screen. It is asking like this. A frictionless wire AB is fixed on a sphere of radius capital R. Look at the sphere. This is the sphere of radius given R. A frictionless wire AB. Look at the AB. That AB is the frictionless wire. This is the frictionless wire that is fixed to the sphere. A very small spherical ball slips on this wire. Look at the very small spherical ball which is slipping along the AB. Let me write that point. Very small spherical ball is slipping along the AB. The time taken by this ball to slip from A to B. What is the time required to slip the ball from A to B? Okay, for that, you know, acceleration of the ball along the AB equal to G cos theta. Then, what is the distance traveled by the ball from A to B equal to ut plus half A into t square, one of the equations of motion. But it is slipping down means initial velocity u equal to 0, u equal to 0. Then the distance traveled by the small spherical ball equal to half into a value g cos theta into t square but the length of the AB length of the AB length of the wire AB equal to, right, 2r cos theta. Now this is the equation 1, equation 2. From 1 and 2, since the LAs are equal, you can equate the RHS. I can write that half into, let me write it clearly, from 1 and 2, from 1 and 2, I can write that half into g into cos theta into t square equal to 2r cos theta. This cos theta part is cancelled. Then I can write that t square equal to 2 into 2r by g. From this, t square equal to 4r by g, or t equal to, right, root 4r by g, root 4 equal to 2 only, 2 into root over r by g. That is the time taken. Look at the option C. Option C is absolutely correct. Understood clearly? Yes. Then let us take the another important problem. Look at this problem. A person with his hand in his pocket is skating on ice at the rate of 10 meter per second and describes a circle of radius 50 meters. That means the person is skating in a ice block in the form of circle, right? While he is skating on the ice, the frictional forces can be ignored. What is his inclination to the vertical? No, by the time he is skating in the form of circular path, there is a centripetal force. For balancing that centripetal force, he must be bent at an inclination with respect to vertical. What is that angle bent by that person with respect to vertical to balance the centripetal force or for avoiding the skidding? Okay. For that, for that, look at the angle of inclination. Angle of inclination. It may be like this, no? This is the person. This is the person. He is at an angle with respect to vertical. Let that angle is theta. This is the angle theta. You know, this is the what mg, the weight of the person acting vertical downwards, mg. Then this is the mg cos theta, because this is also theta, mg cos theta. Then this is the right along the plane towards down, vertical component of weight, that is mg sin theta. That should be parallel to plane. And centripetal force, look at the centripetal force. This is the centripetal force Fc, right, is making an angle theta, developing two component weights. This is the Fc cos theta. Now for avoiding the skid, the centripetal force into cos theta must be equal to, must be balanced by this one, mg sin theta, sin theta. But yeah, what is the Fc? Fc equal to mv square by r, mv square by r into cos theta is equal to mg sin theta. Here you can cancel this m, then v square by rg equal to, I can write sin theta by cos theta, sin theta by cos theta equal to tan theta. From this, theta equal to tan inverse v square by rg. It is equal to tan inverse. Look at the v value. V value given 10 meter per second. V equal to 10 meter per second. Radius of the circular path equal to 50 meters. Acceleration due to gravity g equal to 10 meter per second square. So v equal to 10, r equal to 50. 10 square by 50 into g value 10. It is equal to tan inverse 100 by 500. It is equal to tan inverse 1 by 5. That is the right angle he must be with the vertical for avoiding skidding, tan inverse 1 by 5. Right? Look at the options. Look at the options. Option B. Option B is absolutely correct. Understood clearly? Are you following? Yes. Similarly, let us take the another important problem. It is asking like this. The minimum velocity, which is in meter per second, with which a car driver must travel on a flat curve of radius 150 meters and the coefficient of friction 0.6. Coefficient of friction is 0.6. The radius of circular path, right, equal to 150. Radius of the curved path 150 meters, and is asking minimum velocity. Very simple. Here there is a centripetal force in the curved path that must be balanced by frictional force, that is mu mg, mg into mu. Okay. So Fc equal to what? Mv square by r equal to mu mg. This m part will be cancelled. Then v square equal to mu gr, mu gr equal to mu 0.6 r 150, r value mu g10, g10 or r 150. It is equal to 15 150 into 0.6, 1910, 900. It is equal to 900. Then v equal to what? Root over 900. It is equal to 30 meter per second. That is the velocity of the speed of the car that the driver has to maintain for avoiding the skidding. Option B is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem. Okay. Look at the screen. It is asking like this. A bob is hanging over a pulley inside a car through a string. Look at the string. This is the string. At the end of the string, there is a bar, that is bob. This is the bob which is hanging. Okay. The second end of the string is in the hands of a person standing in the car. The other end of the string, this end is holding by a person who is standing in the car. The car is moving with constant acceleration A directed horizontally as shown in figure. The car is traveling in this particular direction with constant acceleration A. Other end of the string is pulled with constant acceleration A vertically downwards. So the other end of the string is pulling down with constant acceleration A. Then the tension in the string equal to, what is the tension which is developed in the string? The tension may be developed as T. That T is how much? Okay. For that, let's take the enlarged diagram. Here, look at the car. Inside the car, there is a bob which is hanging at the end of the string. At the end of the string, a person who is standing in the car is pulling down the string, right, by holding other end with constant acceleration. Then the tension will be in this particular direction. That tension you are asked to decide. For that, look at the weight of the bob vertically downwards. Okay, and as you know, this is the MA. As you know, the net acceleration is developed in the x of the string, that is A net. That net acceleration I can write net acceleration equal to root over A square plus G square. Then let us write the force balance equation for the string. The tension is acting in this particular direction, and the mass multiplied by net acceleration is acting in this direction. That's why it is minus, because T and this force due to net acceleration is acting opposite. Mass times the net acceleration, that is the net force. According to Newton's second law, this net force must be equal to ma. It must be equal to mass times the acceleration. So T minus m into net acceleration is what? A square plus G square is equal to mass times the acceleration. Therefore, the net tension on the string is m into root over A square plus G square plus ma. That is the net tension. Once again, T equal to the same. I am writing clearly. A square plus G square, A square plus G square plus ma. That is the tension developed in the string. Now look at the options. Look at the option C. Option C is absolutely correct. Understood clearly? Yes. It is very important problem. I am writing as 5-star problem. Means this kind of problem can be repeated in the competitive exams. Okay. Similarly, let us take the another important problem. Look at this problem. It is asking like this. A block of mass m is placed on a smooth inclined wedge ABC of inclination theta as shown in the figure. Look at the wedge. This is the wedge ABC that is maintaining an angle theta. A block of mass, look at the block of mass m, is placed on the smooth inclined plane. This is the smooth plane. Smooth plane means no friction. Okay. The wedge is given an acceleration a towards the right. Look at the acceleration which is given to the wedge towards right, like this. The relation between the acceleration a and theta for the block to remain stationary on the wedge. What will be the relation between the acceleration and theta angle of the wedge, angle of the plane of the wedge, to remain the block on the stationary condition on the wedge? right? That's what he's asking. For that, again, let us take the enlarged diagram. Now, I am going to mark the self weight of the block. The self weight is acting vertically downwards, and as you know, this is the normal reaction direction. So, with respect to normal reaction direction, it is making the self weight is making an angle theta. Let me change the color. This is the theta. Okay, very careful while you are selecting the color. This is the angle theta. Then it is developing two component of weights. This is the mg cos theta, and this is the right mg sin theta. Okay. Now by the time the wedge is pulling towards right, a pseudo force is developed. A pseudo force is developed. Right. A pseudo force is developed like this. Be the pseudo force F equal to ma. That pseudo force is making an angle theta with respect to the normal reaction direction. Then it is developing it is making it is making an angle theta with respect to the plane. With respect to the plane, with respect to the plane, it is making an angle theta, because the angle between the horizontal surface and wedge plane is given theta. Then it is developing two component of forces. This is the ma cos theta, and right, this is the ma sin theta. Now let us resolve the forces along the plane. Forces along the plane. Look at this force which is acting upwards. This is acting vertical downwards. Therefore, I can say that ma cos theta must be equal to mg sin theta to have the block on the stationary condition on the wedge. When these two forces are equal, then only that block is under stationary condition on the surface of the smooth inclined plane of the wedge. Then this m is cancelled. A equal to g into sin theta by cos theta. From this I can write that A equal to g tan theta. That is the relation between the acceleration and angle of the wedge, right? So at this condition, that block is under stationary condition along the surface of the smooth along the smooth surface of the wedge. Okay, A equal to g tan theta. Look at the option C. Option C is absolutely correct. Okay, na? Similarly, let us take the another important problem. Look at this problem. It is asking like this: an object experiences a net force and accelerates from rest to its final position in 16 seconds. It is starting with rest means initial velocity u equal to 0. The time t1 equal to 16 seconds. Okay. So it is experiencing the net force and accelerating. How long would be the object take to reach the same final position from rest if the object mass was 4 times the larger? That means initial mass of the system may be m1 may be m, right? If the mass is 4 times, m2 is becoming 4 times the m, then what will be the time taken t2? That is the question. For that, let us take the one of the equations of motion, s equal to ut plus half at square. Since the block is starting to move from rest, initial velocity 0, then s equal to at square by 2, at square by 2. Then acceleration a equal to acceleration a equal to 2s by t square. For the case 1, for the first case, right, acceleration a equal to 2s by t1 square. T is given as 16 seconds, that we written as t1. Then force F equal to mass times the acceleration. It is equal to mass times the acceleration is 2s by t1 square, right? So the net force F equal to, right, mass times the 2s by t1, 2s by t1 square. Actually this is the m1, this is the m1. Of course m1 equal to m only, m1 equal to m. So finally we got that. But for the second case, for case 2, how can you write? Net force remains same. m2 into 2s by m2 into 2s by t2 square. T2 square. Okay. Let me write it clearly. m2 into m2 into 2s by t2 square. Since net force remains same, let the relation number 1, relation 2. From 1 and 2, from 1 and 2, I can write that m1 into 2s by t1 square. It is traveling for the same distance. S remains same. m2 into 2s by t2 square. This 2s part is cancelled. 2s part is cancelled. Finally, it is m1 by t1 square equal to m2 by t2 square. Okay. But m1 equal to m only by t square t1 square. m1 t1 square. m1 t1 square is given. What is the t1 square? Look at the t1. t1 is 16. It is okay. Otherwise, t1 square. m2 equal to 4 times the m by t2 square. This m is cancelled. This m is cancelled. Then t2 square equal to 4 times the t1 square. t2 square equal to 2 into t1 whole square. This square part is cancelled. t2 equal to 2 times the t1. It is equal to 2 into t1 given 16. That is equal to 32 seconds. That is the time required. Okay. When the mass is becoming 4 times, the time required is 32 seconds. Option B is absolutely correct. Understood clearly? Yes. Similarly, let's take the another important problem. Okay. Look at the screen. It is asking like this. 3 blocks of masses m1, m2 and m3 are connected by a massless strings as shown on a frictionless table. This is the frictionless table. Frictionless table means we did not consider any friction between the table surface and 3 masses. Now the strings connected between the masses and the last string are massless, means you need not to consider the mass of the string. They are pulled with a force T3. T3 is given. T3 equal to 40 newtons. If M1 10 kg, M2 6 kg and M3 4 kg, then tension T2 will be. What is the value of T2? That is the question. For that, let us take the equilibrium position of the 3 masses. For equilibrium, position of 3 masses, namely M1, M2 and M3. For this equilibrium condition, I can write that T3 equal, because T3 is acting at last, m1 plus total mass multiplied by acceleration, m3 into acceleration. From this acceleration equal to T3 by m1 plus m2 plus m3. Okay. Since it is asking for T2. Then let us write for equilibrium position of the two masses M1 and M2. For that I can write that T2 equal to M1 plus M2 into acceleration. For equilibrium position of masses, two masses, namely M1 and M2, I can write T2 equal to M1 plus M2, the two masses multiplied by acceleration. T2 equal to M1 plus M2 into acceleration. Just now we have decided T3 by M1 plus M2 plus M3. Now let us substitute all values. M1 is given 10 kg. Look at the M1 10 kg, M2 6, M3 4. 6. T3 is given 40 divided by 10 plus 6 plus 4. Is it T3 40 newtons? Yes, T3 is 40 newtons. Correct. Now let us simplify it. It is 16 into 40 divided by 10 plus 6 plus 4, 20. It is equal to 640 divided by 20, right? 232 times. T2 equal to 32 newtons. That's the answer. Look at the options. Option D is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem. Look at this problem. Asking like this. Two blocks are connected over a massless pulley as shown in figure. The mass of the block A given, that is MA, is given 10 kilograms, and the coefficient of kinetic friction is 0.2. Coefficient of friction is given 0.2. Block A slides down. This block A is sliding down like this from the inclined plane at constant speed. At constant speed means acceleration A equal to 0. Figure it is clearly given. It is maintaining constant speed. The mass of the block B. What is the mass of the block B? That is the question. Okay. For that, of course, different options are given. Let us take the enlarged diagram. Enlarged diagram. Now, let us write the normal reaction. This is the normal to contact surface. First, let us decide the contact surface. This is the contact surface. Normal to that contact surface. Normal reaction is developed like this. This is the normal reaction. Now, this is the center of gravity. Through the center of gravity, the weight of the block is acting vertically downwards. It is the block A actually. Block A, this is the block B. MA into G, making an angle 30 degrees. 30 degrees. Then it is developing two component of weights. This is the MAG. Let me write it clearly. It is the MAG. It is the MAG cos 30 degrees. And this is the MAG sin 30 degrees. Okay. Now it is given clearly the block is moving in this particular direction. Then the tension is developed on the string in this direction with respect to A, with respect to B in this direction. Tension T. Okay. With respect to B, I can write that T equal to, with respect to B, mass of the B multiplied by gravity constant. Now let us take the body A for block A. Block A is moving downwards. It is moving downwards. For that, this mg sin theta, MA g sin theta sin 30 degrees must be more than the tension and frictional force. Frictional force. This is the net force. This net force must be equal to mass of the A multiplied by acceleration. So net force according to Newton's second law must be equal to mass times the acceleration. Here ma g sine 30 degrees minus t. Right? In the place of t, I can write mv g minus frictional force equal to what? Mu into n. Mu into n. But n must be equal to mag cos 30. It is equal to mass of the a times the acceleration. Since it is traveling with constant velocity, acceleration is 0. Then I can write that mag sine 30 minus mv, right? Otherwise you bring it to other side. mv into g plus mu into n equal to what? mag cos 30 degrees. Cos 30 degrees. Now let us cancel g on both sides. G on both sides. Then it is ma. Ma is how much? How much ma given? Look at the ma. Ma is given 10 kg. 10 multiplied by sin 30, 1 by 2 is equal to mu. Look at the coefficient of friction given, 0.2. Point mb into, take point, very careful. This is mb plus mu value is 0.2 into ma, 10 cos 30 root 3 by 2. So it is 5 equal to mb plus, this is becoming 2 cancel, plus root 3. Therefore mb equal to 5 minus root 3. As you know, root 3 value is 1.73. 5 minus 1.73. Here it is 3.27. That is the mass of the block B. 3.27. So 3.27, approximately option B can be selected. 3.3. Understood clearly? I am trying to explain the each and every point at your understanding level. Understood or not? Yes. Then let us take the another important problem. Look at this problem. It is asking like this. A block of mass capital M is pulled along a horizontal frictionless surface by a rope of mass capital M by 2. It is like this. There is a surface, frictionless surface. Over that frictionless surface, there is a block of mass capital M. It is pulled by a rope. This is the rope. Mass of the rope is capital M by 2. Right? So at the end of the rope, force is applied. If a force 2 mg, that force F equal to 2 mg given, is applied at one end of the rope. Okay. So this is the rope. The force with the rope exerted on the block is, what is the force exerted on the block by the rope? That's what he is asking. For that, let us write the force balance equation. This force must be equal to m by 2 plus m times the acceleration. This force is given as 2 mg. Here it is, let us write the m outside, 1 by 2 plus 1 into acceleration equal to 2 mg. This m is cancelling. Then it is 3 by 2. 3 by 2 into a equal to 2g. From this, acceleration equal to 4g by 3. That's the acceleration. Then force on block by rho F equal to mass of the block into acceleration. It is equal to mass of the block m into acceleration is 4g by 3. That's the answer. 4mg by 3. That is the force acting on the block by the rope. Look at the option C. Option C is absolutely correct. Understood clearly? Yes. Similarly, Let's take the another four problems complete. All the problems what we prepared completed. I hope all of you clearly understood all the problems what we discussed. Understood or not? Yes. Thank you. Thank you very much. Right?
Geobyte.